Okay, now let's try out an example here. Don't touch the thermostat. So what do we have? Well, we've got a heat pump. Cool. It's used to heat a house. Nice. During the winter. The house is to be maintained at 21 degrees Celsius at all times. The house is estimated to be losing heat at a rate of 135,000 kilojoules per hour. Woo! When the outside temperature drops to -5 degrees Celsius. I want to figure out what's the minimum power to run this heat pump. Now, this is a great problem. The reason it's a great problem is because we're going to use both equations for our coefficient of performance to figure out how to solve it. First off, let's have a pretty picture. Okay, here it is. Got my house, 21 degrees Celsius. I've got work going in. Why is it going in, not going out? Because this is a heat pump. It moves energy. It does not produce energy. I've got cold outside air where I'm stealing energy and I'm putting it into the house. Now, let's calculate the best possible coefficient of performance in this case. Why? Because it said minimums. If you ever see the words minimum or maximum, think Carnot when it comes to thermodynamics. It is saying, think Carnot. Yes, that's not realistic. Yes, you can't have that in real life. But think Carnot because that's where you're going to find this minimum or maximum performance. Okay, so that being said, we're going to use the Carnot equation for a heat pump. Now, if you don't have this memorized, who cares? Because even if you use the wrong one, like you accidentally use a refrigerator one, you'll just get a negative number. If you get a negative number, you use the wrong one. That's all you have to realize, okay? If you get a negative number, you just use the wrong one. So check that, and it should be fine. And actually, I'm not even sure you'll give a negative number. That's for another time. Okay. So, with that being said, I plug it in here. Note I have my absolute units. That's why I had to add the 273 to each of those. Always absolute temperature in this course. I get a max coefficient of performance of 11.3. So the best I can do in any situation for these temperatures, -5 outside, 21 inside, is to move 11.3 units of energy for every unit of energy I put in. Okay, so that helps me out. I even just kind of gave you the answer right there because it said the next thing you need to do is to not use these like cut and dry equations, which are just plug and chug, but to actually use the thinking about it equations. Because remember, your coefficient of performance is simply how much heat did you move over how much power it took to do it. That is all it is. How much heat did you move over the power it required to move it? Now, how much heat am I moving? Well, if I want to keep my house warm, if I want to keep it from getting colder, I have to make sure I'm putting in as much heat as is exiting the heat through my poor insulation. So, in that regard, I can rearrange this to solve. As a note, 135,000 kilojoules per hour, well, that's 135 megajoules per hour, which comes out to be 11.94 megajoules per hour when I divide it by my coefficient of performance. How did I get to kilowatts? Well, 11,940 kilojoules per hour. Well, 1 hour is 3,600 seconds. Kilojoules per second, that is equal to a kilowatt. And so from that, we have our answer. Don't ever forget this equation right here. It is always, always helpful in this chapter and other ones. Just remember where it comes from. Every other equation can be derived. This one is the simplest, and it's usually the most helpful. Okay, now another question you might have for yourself is, well, so I'm going to use 3.32 kilowatts no matter what. That's the best case scenario, which means in real life, it's going to be more than that. That's supposed to be a more than sign, but I'm doing it in a really strange place here. So my power in real life is going to be more than 3.32, which means I'm spending more money to keep this running. How can I reduce it? Well, it's not all that crazy. If you want to reduce your electricity costs when it comes to heating, number one, you can reduce the temperature in your house. If I go down to 19 degrees Celsius, my performance will increase. Also, the amount of energy I'm losing from heat loss will decrease too, because it's based on the temperature differential. Second thing you can do, better insulation. Fill those walls with insulation, okay? Fill them all with insulation. My house, the studs looked like this. There was nothing in between them. I have done my best to add as much as I can in there to make it a little bit warmer in the winter. So those are 2 ways you can improve your performance. Well, that's it for this problem and for this chapter. So thank you all for listening. I hope this blessed you, and I'll see you all next time. Bye-bye.